This is 2005 question 1b. We have a mass of 8 kilograms falling freely from rest. So we have initial speed of 0. We have mass is 8. So I've got some forces going on here. After 5 seconds, the mass penetrates sand. So T is equal to 5. The sand offers resistance. What we call this? We call this resistance K. And brings the mass to rest in 0.01 seconds. We've got another time here. So two things going on. It's falling, and then it's hitting the sand, and then it's stopping. So we need the speed when it hits the sand. And we've got forces going on. Force is equal to ma. It's falling in this direction. We'll give a positive. Mg is 8g. So we have resistance from the sand, which we call K. It's going to be opposite direction, minus K. So we're going to have 8g minus K is equal to 8a. So we need acceleration. We need the dog to stop snoring, but we need acceleration and we need K. We obviously need K for part 1. I think constant resistance sand part 1. So let's have a look here. So let's get speed after 5 seconds. So let's get V. A, it's falling freely under gravity. After 5 seconds, it's starting at rest. V U AT. V is equal to U plus AT. So speed when it's starting from rest after 5 seconds, when A is G, will just be 5G. So we leave in terms of 5G meters per second. Then it hits the sand and comes to rest. So its new speed is 5G. It comes to rest. We have to get the acceleration. Given the time. So VUAT again. V is equal to U plus AT. So comes to rest. It's traveling at 5G. And we're looking for A, 0.01A. So we're going to get A is equal to 5G. So minus, just to get in there, minus 5G over 0.01. And to simplify that, we'd multiply top and bottom by 100 to get rid of the 2 decimals. So we're going to have 500G. A is equal to minus 500G, the acceleration when it hits the sand. Don't forget your units. So now, what have we got? We got enough to fill in our forces. 8G minus K. We have A, so 8G minus K is equal to 8 times minus 500G. So bringing K to the right to make it positive, we're going to get 8G plus 4000G. So the resistance force will be 4008 newtons. 4008 by 9.8 will be 40080 minus 2%, which would be 400.8, giving me 39278.4. Just double check that in the calculator. Newtons for the resistance force in part 1, and then the distance traveled into the sand. So we're looking for S into the sand. It comes to rest. It's traveling at 5G. It's my U. And we have acceleration of, what do we get? Minus 500G. So S U vs V squared is equal to U squared plus 2AS will give it to us. So 0 is equal to 5g to be squared. The speed it hits the sand at, plus twice my acceleration of minus 500g times s. So bringing 1000g to the left, it'll be positive, so we're going to have 25g squared. We're going to have 1000g times s, so s, and bring the 1000g underneath. S will be equal to, we're just going to divide by 25g, so we're going to have g on top and just 40 on the bottom. 9.8 divided by 40, it's 98 centimeters divided by 4, which will be 25, that's a half, 24.5 centimeters. And again, just double check that on a calculator.